Hello. Yeah, welcome to the live channel. Yeah, so hello, welcome to the live channel. And if you are joining, would be better if you try to send me a message or a hi, because I'm actually streaming from a different platform. Yes, so today, again, my name is Aiken, and this is Aiken Network Studio. So we would be recreating a lab that I already sent through on my channel about most 5 days ago. So we will start all over again. I already do have um, the lab here, as you can see. Can you guys still see me though? Trying to make my video as small as possible. Okay. All right. Yes. So we'll be using GNS3 for this lab. So first thing first, we have to check the configurations I have on this lab. Firstly, you have to start the lab. Yes. So we're starting our lab. And this is actually, I'm going to explain what this is. This is called dynamic multiple VPN. So in a dynamic multiple VPN, you have numerous sites that you want to carry over this tunnel. This is the remote site 1, remote site 2, remote site 3. So you can call this remote site 1 anyway, because this is the headquarter. It's actually the hub. So we're going to be using hub and spoke technology. The hub is going to be the main site where the spokes are going to depend on. So we have here as a hub, we have here as the spoke, and this another spoke. So we should have a connection in the middle, which is we're kind of simulating a cloud, which should be the internet. So a service provider has to give you IPs for you to be able to connect your router to different sites, and you're gonna carry a tunnel. You're gonna use a tunnel to carry your traffic. So there is something called generic routing encapsulation. That's the GRE tunnel. So GRE tunnel are not secured most of the time, so we need to use an Ipsec to secure our tunnel. So I'm going to open each and every router. So there are configurations on them already, but I'm going to deconfigure them and we will configure them. So it's router 4, right? And 3, which is the hub, 1 spoke and 1. So have it in mind that we also have some DHCP configurations here as well. So I'm unable to see who is joining. So if anyone is joining, you can please say I if you can, right? Because it looks like I need to sign in to chat or something. I don't know what that is. So I'm not gonna sign. Yes. So this is the router 4. Let's name it ISP. Sure. So I want you to see what we have on this already. So we have an IP address on router 4. 0/0. Let me do this. Make it easy. Hopefully this is gonna work for us. So we have um, all of the subnet 10.1, 2.1, and 3.1, all in /30. So this is 10.1, 0/1, 1/0 is 10.3, and 2 and 0/0 is uh, 2.10.2. So here as well, we'll also have a point-to-point address on R1. I'm just trying to show you the configuration. So you can see that we do have a DHCP configured on this router 1, and also the interfaces. The crypto IPsec, I'm going to tell you that later on. So we have a configuration already here as well. Sorry, I just want us to go straight with the interface first. So we have this interface 0/1, which is this network, and we also have this interface that goes to the ISP. So let me just rename this thing. You can say site 1, site 2, or pop. So I'm just going to name site R3 pop. That's what I'm going to do that. I could just poke to the rest to make it easier, I guess. Good. So now I've already shown almost every, I think I didn't show this yet. I'm just trying to show the configurations I have on it. Just the interface for now. So if you're just gonna watch this lab just to see how it's done, you could definitely recreate your lab as well. Because if I say you could not start creating it right now, it might not really work for you. So yeah. So this is the interface. Oh, so did we go out of the interface? Okay, let me just don't do this. Let's just do it all over again. Could have just shown the interface I was talking, so I didn't see it. We'll talk about the tunnel as well. So these are the interfaces on R3. 0 slash, this is it. 0/0 is this network, and 0/1 is this network, right? So let's continue from deconfiguring this. What am I gonna deconfigure basically? I would love to deconfigure okay, again, this is an underlay network, and this tunnel is gonna be an overlay network, right? So let's deconfigure it because we just have to recreate the lab, like I said. So let's do a show run, and we deconfigure by the show run. So the DHCP, do we need to do that if you guys want? But I think we should just leave the DHCP, right? Because I believe you guys know how to configure DHCP. If you don't know how to configure DHCP, I think I have a lab for that. before. That was on a firewall, so you could always look up that. It's just few um, commands to get that done. No crypto. So I'm trying to take out this that's gone. So yes, I have to remove that. Give me 1 second. I need to check some. Oh, sorry. Do show run. Okay, so no. This is where we need to take out the protection. So when we take that out, you can see it's off. Then we can continue with what we're doing before that it didn't work. Now we can take it off. Let's go back to get the rest out. So technically, we already took out the Ipsec from the tunnel. So know this as well. Oh, sorry. That's gone. Then know this. It's easier to copy and paste configurations than removing them. Okay, this is not gonna work anymore because I think all is gone for that. See, the the path for the IPsec is gone already. So we're just gonna say, should I take out a tunnel? Yes, I should, because there are some things we need to talk about here. Without that, you might not really be able to form a tunnel, or you might not be able to form the point to multi-point tunnel. Okay, so I think this should be all I want to do for this part. It should be good now. Okay, again, if you want, you can also take out the BGP so that I can form that later on. Yes, we should. No router BGP1. So everything is done now. So we are all over the place already. Right. So we're doing this. Right. So we were using router. Yeah. Mhm. This is for the tunnels, which are already detached. Right. So let's go on R4. I don't know if anyone is writing me, so let's check if I can see it. Doc, chart. Chart is loading. Okay, cool. Yeah. Okay. So R4, you can see all we're doing here is we're forming route BGP ERGRP with all of the connected routes. Please disregard the 10.0.0. I actually used that before, but not anymore. Yeah, I believe so. Yeah. Hmm. No route ERGRP1. Everything is gone. So there is no tunnel on this one. So we don't have too much to do here. It's just, um, regular configuration. That's all. So let's go to spoke one. Oh, I have it already. Sorry for reopening that. Just keep reopening stuff so I don't have to. Spoke one. A whole lot has been going on spoke one. Show run. So let's have it. So we can quickly take out. You should have tunnel 5. You should have a whole lot of stuff there. So we're just gonna do almost the same thing we did on the previous on the hub. So I would rather take out the tunnel straight away. So that's gone. So even this is tunnel. Okay, cool. So no crypto. Let me leave that one. See, that doesn't even work anymore. So let's just take this out. Good. So we're also gonna leave the DHCP service. We're not gonna touch that. We have the BGP to connect the tunnels, and yes, yes, we have the BGP to connect the tunnels, and what else do we have? And we actually network the site IP address on the BGP. So I'm overlay network, as you can see here, it says overlay network AS1. So almost all these are very explanatory about the lab itself. Oh, so what did I do? I wasn't checking. What? Oh my goodness, what am I writing? No router, BGP1. We should almost be done with this. Good, thank you. So let's go to the last one. We're gonna do almost the same thing. Again, it's fine. I got it. Gotcha. No route to BGP1. It's gonna be the same. No interface. Tunnel 1. Okay, guys, I'm sorry. My stuff gets disconnected and reconnected again. No. So Ipsec profile. All right, good. We should be good with that. So show run again. It's gonna be a little bit long lecture, is it? Well, what can we do? Yep. So look at it. So we have router ERGRP, and this is actually for which actually I didn't check that, but you know I'm just gonna take that out because just have to start from fresh. Dang, good job. So I think we're all clear regarding whatever we've got on this network. We just left the DHCP server, DHCP configuration, giving IP addresses to these guys. That's the only configuration we have on this network. So now we're going to start right now. So we're going to start with router 4. Show IP interface brief. Do show IP interface brief. So you can see we already have some configurations on this. Have it in mind, it's /252. So we're not going to go there. So what do we have to decide right now is we have to be able to reach all this part. Now show IP route. We have, oh, I'm sorry, let me just go ahead. Okay, cool. So we should just have connected routes. So everyone can ping their next hop. This is the 1, the 2, ping the 2, ping 2, but you cannot ping everybody can ping their next hop, but you can't ping this network. So you can't ping the next hop for now because you know there is no connection, you know. So firstly we have to establish a route now, yeah. So what do we want to use? I would prefer we use I don't know what did we use before. I can't remember. But again, I want you to know that I already have the configuration also pre-written here in case we need to, you know, check some configurations. And I'm going to explain these configurations step by step. So most of the time I have it all here. So for the ISP, we have ERGRP there. So I'm going to do exactly that. Do you know why we're doing that? We have to set the underlay network first before we build something on it. The underlay network are physical networks, while the overlay networks are virtual networks. So that's what the tunnel is going to be built on. So router ELGRP1 network, sorry, 172.10.1.0, right? Which is this network. So you know how to calculate wildcard mask. If you're here, I'm sure you know how to do that. If you're interested in watching this video, I'm sure you know how to calculate that already. So it's forming those stuffs back because it's already configured and hop 2 and 3. Okay, so now we're not going to actually even go through this because our plan is to carry this site, and this site with the overlay network, not the underlay network. So we're not going to network these on the router, right? So this is the first thing we need to do. There is already configured, there's already a connection now between here, and here, right? So, and ping 192, sorry, ping one from here. Now let me come here because it's gonna be able to ping everybody. So let me just come to R1, right? So let's say ping, do ping 172.10.1.1. It's gonna be able to ping. We ping in this direction. That's the first one we pinged. Right, sorry, here. Now let's go to 2. So we can have your reachability now on the underlay network. So that's the first thing we do. Then when we have a reachability on the underlay network, then that's when we're gonna build a tunnel. So configuration for our tunnel is gonna be done on these routers. There's nothing with this anymore. So we do that on the spoke 1, spoke 2, and hop. So interface tunnel, we're still gonna use 5, right? So it's hop, yeah. So we have to do a lot of configurations for us to be able to get to what we want. So the tunnel source, you have to look at whatever you want. You can use the interface, right? But you can also use the IP address. So for guiding, I can just copy and paste all this, but I don't want us to do that. We should just go through it together, easy, that way, so no one makes any mistake. So this is for spoke 1. We're already done all this, so you can see there is something called NHRP. That's Next Hop Routing Protocol. That's what the tunnel use to actually form to know where to send a packet, to actually know how to form the spoke to spoke kind of connection and the spoke to hub kind of connection. So in this case, you also can also have a Cisco kind of documentation that's going to tell you more information about this. So your tunnel source should be here, or you can also put the IP address if you want. Yeah. So FA 0/0, right? So you could actually have this here. We could be doing it one by one, but if any of them need explanation, I would definitely explain that to you. So the IP MTU, this is something that you have to just put there, 1,400. That is the maximum transmission units, right? So the MTU, so that's the size that you can actually transfer to the tunnel, and there's going to be a reduction in that, which is going to be the MSS. So for you to be able to go through the tunnel without being fragmented, right? So you could also, now you have to put the IP address to the tunnel. So in this case, we're going to be doing .168.254. So as you can see, this is what we have here. .254. This is going to be .2 because we have .1 here. The tunnel we're going to be forming here is going to be .1, and we will be mapping whatever we have here to the main hub. When we get there, I will explain that to you. There's going to be configuration. In fact, even on this tunnel, yeah. So this is going to be on subnet. This is going to be a /24. It could be whatever you want, but /24 is good. So you can always do this. Next up, routing protocol. Do this. You can see a whole lot of what you have to do, right? So it could be authentication, and the authentication has to be the same. In this case, I use something called Shiko. That's the word Yoruba. It means don't say anything, like quiet. That's my that's my dialect, isn't it? So you use that. If you want to know more, nothing. There's still a whole lot more configuration. There's NHS. There is some, the ones you're gonna use here. You're gonna map authentication. You map network ID. Could be anything, but make sure it matches. 99. This is gonna be used for something else. Registration, responder server only shortcut. We're not gonna use too much here. So all time, map. So we're gonna use that. So, but I just want to make sure that we've been guided by this because there's no reason to not use this. Yeah, I've done that. This is the map we're gonna map. I've done this. We have to have a source as well, but let's deal with the NHR piece, right? The old time, the NHS, right? So let's map it. Yeah. So you have to map whatever configuration you have in, right? You have to map it to the hub, right? To the tunnel of the hub, and as well to a point on the service provider. So IP NHRP map, right? This is what we want to map. So you're not mapping yours, you're mapping the address of the hub. Right. Look at this. It's going to ask you an IP NBMA address. So the NBMA address is this. So that's like, well, if we want, we could actually quickly Google that because I did not really take note. Actually, just give me a moment. Oh, sorry. Oh, I don't know what this is giving me. So just give me a moment. I might have made some mistake. So NBMA, sorry, NBMA address. So non-broadcast multiple access. Sorry, yeah. So it's the non-broadcast multiple access. So the non-broadcast multiple access network, does not support broadcasting or broadcasting. You can just read this, but basically you have to. It's a dynamically learned by using the NHRP. This is the next operating protocol to register and query of other system. So that's what other tunnels are going to use to be able to query, to be able to register themselves dynamically and being able to communicate with the spokes and also be able to communicate with the hub without any physical network. Right. So that's about that. Uh-huh. So that address is going to be this one, which is 172.10.1.1.2. Sorry, it's going to be on the router itself. The 2. It's going to be this one. Yes. Uh-huh. 2. So again, there's more things we have to do. So in terms of multicast, right? So in terms of multicast, we can also going to map multicast to the same. So we'll map multicast. Yes, the same. Right? So that's what we need to map. And also, we're also going to check again. So any chest, so that's going to be 192.168.2. Because that's actually needs to be done as well for you to be able to have the connection to the hub dynamically. To create a generic routing info encapsulation kind of tunnel is easier. You just have to get it done, and you don't have to go through all this. Yeah. So again, you should have to have a tunnel mode. I will get there later on. So I just want us to get done with the the next up routing protocol part. We've done almost all this, and now the old time. It has to be the same all over, right? And we have to do this as well. So the old time, IPNHRP, old time 450. Yeah, just check. Could be from 1 to 65535, but Cisco recommend 450. Right. So I think for that we should be okay for the NHRP configuration. So also now let's do the rest. TCP adjust MSS to 1360, because that's better, because there are some subtraction that has to be done when you actually configure your MTU, because what you configure for MTU is not going to be the whole size or bandwidth that you're actually given the tunnel. So it has to subtract some points from it, so you can actually read up that. But that's what's going to happen. So that's why we're doing the adjust MSS 1360. So delay 1000 might be optional. Not everyone does that. And bandwidth 3000. Whatever you like, put that. So it depends on whatever you want. So now we've done tunnel source. Now the tunnel mode. We're on the hub. We're not on the hub. Okay, so we're not on the hub. Yeah. So the tunnel mode, normally GRE multi-point. But if you're trying to do a point-to-point kind of connection, let's say you're doing a point-to-point kind of connection, then you have to need a destination, right? So, but in this case, it's not like we know the destination, because it's going to be dynamically assigned. So in that case, tunnel mode. So you can also do this to know what you can do on your tunnel. There's a whole lot. So you see, you could do checksum destination flow mode, but we'll be using mode key. We've done source already, so that's all we need to do here. Right, so the mode, you see, so the mode could be this, right? Could be GRE, could be Ipsec, could be IP talk, could be everything. But today, as you can see, our mode is going to be GRE multi-point. So this is kind of different. DVMRP is not DMVPN. This looks a little bit confusing, so don't trip it. So as you can see, it's also a mode GRE, generic route encapsulation protocol. Right, the tunnel is hot because it's actually able to get to the multi-point, right? So that's the mode for that. So we've done the mode. So about key, because the key has to be unique everywhere. Tunnel key. So you can give it whatever you like. I give it 1, 2, 3. It has to match, yeah, on all the rest of the tunnel. If it doesn't match, it's not gonna work. So we should be done with the configurations of the tunnel and everything here. So one more thing we've not done. This is actually just a generic kind of like tunnel. It's not secured. So I would get back to the configuration of that. Right. So for DVTM there is also things called phase 1, phase 2, phase 3. So the phase 1 is when you're actually forming a point-to-point, where you're actually specifying a destination. And the second phase is what we're doing right now, which is the multi-point. And the third one is like a shortcut. That means that when the IP address from one of the tunnel changes, especially one of the spoke. So when it changes, then the non-broadcast MA, multi-point address, or what we checked here already, DMBA, should actually not be expecting an exact IP address from the spoke. So when it wants to request, when it wants to register, then it's going to be able to register without a problem, right? So that's where we have an additional kind of, this is it, an additional kind of configuration, right? So, well, if we're going to get there, I'm going to let you know, but the major purpose for this is just to get you GRE multi-point running. Good. So, at this moment, we are able to configure the spoke one. Right. I believe that's what we just did. Right. So now let's go to the hub itself. This might have a little bit of different configuration. So on the hub as well, we already have everything. Interface tunnel 5. So we do almost everything we did there. So can go to the hub as well. So we do almost everything I already said. So IP address 192.168. Well, I can just copy and paste it. You all know that already. So let me just copy and paste all this so that we don't waste our time. I already configured this, so I can start from here. Just for the tunnel, I don't want to do anything else. Okay. This can help you a lot. So this is it. So I already have the interface tunnel 5. Paste it. It's just going to run through. If it's wrong, then you're going to have some error and you have to correct it. I've done that multiple times, so I know it's going to configure it just the way I want it. So it's changed to up. So we're just going to copy and paste also for the third one. Spoke 2. So this is just going to configure also from interface tunnel 5. Yes, because there's no reason we have gone through this already. So it's going to be the same. But I'm going to explain something on the hub. So the R2 is going to have the same thing. So we already have a tunnel. So, but let's go to R3. There's a little bit of difference in R3. I should have told you guys. So in R3, which is the hub, so in R3, which is the hub, there's a difference. These are very important information. No IP next up self ERGRP1 command. Right, and this actually works also if you're using an ERGRP. And in our case, we use the ERGRP, right, to connect these guys here. Yeah. So from here to here, right? We would definitely use it because it looks like I don't even know maybe yet, but that's what I used it for. So if you're using ERGRP, you have to do this. No IP split horizon ERGRP. Well, if you try with a different protocol, maybe you might not need it. But when I was doing it, I was using ERGRP. So yeah, if you try with a different protocol, maybe you might not need it. I'm not sure. So, but these are very vital for you to work if you're using ERGRP. So IP and HRP map multicast now is dynamic, right? You're not mapping it to an address just like we mapped it to an address here, right? Just like we mapped it to an address here. No, I don't have to do this. We map multicast to an address, but in this case, it's actually dynamic. So those are the changes you have. And the source is actually, the outgoing interface. Source outgoing interface. At this moment, I didn't put FA. I didn't put, whatever this is. FA0/1. I did not put that. So yes. So yeah. And the same thing for the rest. So I actually kind of repeat this twice, for some reasons, but no offense, it's not going to configure it twice anyway. So yeah. So that's that. So that's the configuration. So now it's gonna be tunnel ready. Show interface. Show IP interface brief. So we already have a tunnel configured. Now let's ping our tunnels. Let's see if this configurations is correct. We should be able to ping our tunnels now. So we can ping .1 and .3. Let's see. We can ping .3. So we're not able to ping .3 yet. There's an issue somewhere. Okay, so there's an issue somewhere. I'm gonna try again. Okay, so now this is .3 here. We're gonna check again. Maybe there's something wrong. Delay. I don't think this delay was done. Wait. To show run. $1,000. So let's see what effect that has. Okay, it has something to do. So I'm just gonna inspect this one and see what happens. So I think it's up. Okay, so it shows that there's still something going on. Ping 192.168.254.1 is gonna be ping that one. Okay, so it can't even ping that one. So there's definitely something going on this tunnel. Yes, so that has to be investigated. Troubleshooting section. Yeah, good job. Okay, so is this connected correctly? Done. Can you ping? Oh no, oh, that was wrong. Okay, you can go through that. Okay. Mhm. They're just trying to different router. That's all we have. Maybe there's no routes here. Well, this should not be an issue because I'm not sure I have the same. The issue is going to be here anyway, but I'm going to inspect that correctly. Mhm. R1. Because we should not have that trouble. Yes, this is what it is. We have to be sure we're doing all this. Okay, this already have a route, right? So, I think we're almost getting there. So let me do this again. Uh-huh. You see, there's a difference already. You see, there's a big difference. So it's actually not forming ERGRP with this. Show IP, show IP ERGRP interfaces. So it's having 0/1, 1/0, but this is not actually having any. Nothing. So that's the reason. So troubleshooting has to be done. Then when you're doing the troubleshooting correctly, you will know what the issue is. So you see, it should have three. So it's not having to the last one. So that's the problem. So now we have to do that. Now it's up. So interfaces now enable. Now good. So now let's see what happens. Now let's see what happens to the tunnel now. We should be able to ping the tunnel. Let's wait. Let's see. We're still not able to ping the tunnel. See what happens again. So, yes, or let me see if I can ping. Okay, this is gonna be another case. Okay, I'm able to ping one now. So can I ping two? I can ping two, so it's all good now. So I should be able to ping three. I don't know why it took some time. Yes, good job. So now we have all the tunnel function here. So we have tunnel function here, tunnel function here, tunnel function here. Right. So now let's show something. Show MIP multi-point VPN. Oh, sorry. Show IP. DM VPN. Sorry, give me a moment. Uh, yes, so DMVPN. So do you see what's going on here right now? Um, it's already forming, over this tunnel, right? As you can see, non-broadcast multicast address. Give me 1 second. There's something I want to just confirm. Non-broadcast multiple access. Non-broadcast multiple access is querying to this through this, and this is the tunnel, and it's going to a static, right? And this is what we call multiple. Um, this is what we call dynamic multi-point VPN. So this is dynamic anyway. As you can see, the D is dynamic, the S is the static. So we have that on R1. So let's see if we have the same on R2. It's a little bit problematic one. Yes, we do. So you can also show NHRP, right? For you to see, more information about, I've created this and so in this case now we're able to achieve this. And don't forget, I know that we have to create the profile for the Ipsec. Creating a profile for Ipsec, you just have to know it. It's not like the reason for this is why this is this, why this is that. You just have to notice. Yeah. So I was just trying to unconfigure it, the configuration, but we didn't do it. So I would just go for the configuration itself. So I have it here. So we have to configure these on all of the um, three we're actually dealing with. So let's do that. So R1, config tab. You have to create the profile. Crypto, yeah, the you check. It's always easy to do all this. Yeah, policy one, first one. Then check here. You can copy and paste this if you want. So, but I'm not copying and paste at the moment because I'm just gonna say one or two things. Encryption 3DES. That's the encryption is gonna use on the tunnel. Authentication pre-share. Then crypto. I know I didn't write this right. Oh, we're already there. Yes, so just check. What else do you need here? Um, mhm. So exit, crypto. Next thing is crypto Ipsec profile. That's the first thing you have to do. I'm using this, right? Fasty, set, transform, trans 2. I'm just using this. It could be anything you like. Look, it's going to tell you what. So it's whatever you like. I'm just using this. It does not exist. So give me a moment on that. Yeah, you have to do that first. You have to create that. Crypto. Oh, no, it's not this profile. Exit out of this. Crypto Ipsec transform sets. That's the one I was talking about. Trans 2. I'm just using that. Then you now need to talk about what you need to use. So I'm using ESP to 3DS. So it depends on what you want. 3ds, and I'm also using another one, MD5 HMark. Now you already created trans here. So do this if you want. That's all. Then now you can see crypto IPsec profile fasty. Let's go again. Now set. So you can see it tells you can set here, set transform, set trans2. Wait, still the same thing. Oh, trans2 does not exist. But wait, give me a moment. Set transform. Okay, give me a moment. I could have I possibly skipped a step, which I should not have skipped. So yeah, but give me 1 second. Let me try this. Give me 1 second. Let me try this. I have this everywhere, so I would have skipped a step, which I should not have skipped. Just give me a moment. Let me try this on R2. Yes, I definitely have skipped a step when I was trying to configure this. So it has to be in order. Right, so we will try that on the R3, yeah? So I'm just gonna do this, right? Okay. So, but we're gonna have to do it on R3 in order so that we understand what we're doing. Exit, like crypto policy 1. It just has to be in order. It's not like there is one explanation for this. Yeah. So this was where I was actually not getting it right because I was out, right? So here it's already on this. I just think that crypto, no, can do this. Yeah. Okay, so if I would just do this. Set p exit, set p fs2, crypto IPsec profile fasty, set pfs2, right, set security association lifetime, seconds 1800, exit, crypto IPsec transform, set, and we have this has to be the same, ESP 3ds ESP mGRE HMark. Yes, so set trans already set transform too, so it's already done. So that's the reason why I think um, it wasn't working, because we're already in the set transform, yeah. So the transform that I set was actually 2. So there's no reason trying to do that again. So exit crypto ISA can be the key, right? Key 6. So you have to put a password, word, UD, then address. It's going to be all address. Good. So for the last time, let's try something. Crypto. Sorry, let me turn on my light. I don't know where it went. Yeah, crypto. Ipsec profile fasty set transform set transduce. That's it. So you just have to follow the order, for configuring it. You just have to know how to configure it as, now a security engineer. So I'm doing IPsec. You just have to know this and know what steps you have to do next. But the most important thing is you just have to know that you're mapping on this address and you're choosing this. Whatever you like, you can put here. Whatever you like, you can put here. So that's what matters. So in this case, show run interface tunnel 5. We have everything. Show crypto profile. Yes. So wait, let's see even if after this IPsec profile, if we're still able to ping. Yes. So which shows that everything is working fine. We have key encrypted. We have profile fasty. Okay, there's nothing here. We have policy. Right. So show crypto IPsec. Okay, now it's a form profile. We have for fasty. We're just trying to check what we have. That's all. So from the look of things, we already have all the tunnels working. Good. So that's the most difficult part we've done. So as you can see, we already formed all the underlay networks, and there's an overlay already, which is the tunnel. Now the site here has to go over the tunnel, right? Not over the physical network. We could have the option of taking it over the physical network, right? But as you can see on R1, show IP route. See, these other networks came through, and this is just directly connected. You can't find it on R3 now. So you can't find the network on R3 yet because it's not, advertised anywhere. So you can see, and you're not gonna see it here It's going to be on the tunnel. Well, you might see on this table, but it's going to be carried over the tunnel. And we'll check that later on as well. So let's start by forming a BGP section over the tunnel. Right, so let's start from R1. Router BGP 1. So neighbor 4.1 remote AS 1. It's going to be an internal BGP. That's 1. 10. For you to do that, there's going to be another one that says activate. You know, because it has to be ready for BGP connection. Right. That's 1. So on R4, sorry, on R3. Dot 2 remote AS 1. That's the 2. And at the same time, the 3. Right, because this is 3 and this is 2. Right. So, right. For some reason, this should be almost forming out. If I get that correctly. So already have it with it in 4 seconds ago, and the BGP already came up here as well. So I already established BGP here as well. You can see the cool thing about this is they are all in the same subnet. And on a normal day, in a physical network, it's not possible to have 2 legs on one, It's just, it's just cool. I don't know how to explain that coolness, because you're going to form a connection here from what I illustrated here, and you form a connection here, right? So this is going to have 2 legs, and this is going to have 1 leg, and the both legs are in the same subnet. So on a physical network, you cannot have it; it's not going to work. So, but on overlay network, that works. So now let's go to R2. Router BGP 1 neighbor okay, it has to be both side, right? Just 1, sorry. Okay, because that's the way it has to be. So you can also confirm from here. That's all. So, okay, I think I use the GRP for this one. I believe so. But I'm already using a BGP now, maybe. Yes. Okay, GRP could be cool. But yeah, we're already using a BGP. We can also use the GRP, but yeah, I didn't use that. But let's see. So in this case now, let's swipe it out on R3. Good. We're not networking anything, so show IPBGP summary. So it has it with both of them, and this also have to be both of them. right? So in this case, let's try one more thing. Just a full adjustment. Sorry. Yes, the output 1 and 2, right? So this one is going to have 1 and 3. Oh, it's still active. So now it's up. Right. So now that this happened, we're just trying to, get the connections right. This is still what we have. Yes. But at this moment, I can tell you that what we have to do next is just we just put on the networks now over the tunnel. Right. Because we were using the GRE here, right? So now we're using BGP here. So when we use BGP, it's going to be a different network. So we'll be able to trace route. What route are they taking? Right. So again, on this router, okay, let's do it from one router BGP1 network 1.0 mask. So now what would you see? Go to R3. You should see the BGP of network 1 already here. And you should also see it on here. You saw it here already as well. So let's go to 2. So it's going to be there, and you do the same here. So now we should have a full match, but they are all carrying this via, not R4, sorry. So they should all be carrying it via the tunnel. So this is connected. This is BGP, this is BGP. See, they are all carrying it via the tunnel, right? So now, if you try to ping, now let's go to these guys now. Now they are ready to work. So we connect. Okay, I have to reload this one. Actually, VPCs, so everything has to be reloaded. Okay, so now let's try. It's working now. So we already have a DHCP on this thing, IP DHCP. So you got an IP address. Good. So ping 192 dot. Okay, I have to put address on every other stuff. I just want you to know what route are they taking to get to the destination, right? Okay, R2 is still malfunctioning. PC2 is still malfunctioning. So let me do it again. You know, this guy's not that stable, but that's what I've got for JNS3. I'm not gonna use a Mozilla or Chrome because these are for some other testing purposes. In my previous lab, I have this there, so you can also um, watch how I simulated connect how I connected the sites to the internet. Yes, so we have it right now. So now the thing is, one more thing I need to test with you guys. So I think to this brief here. So again, let's come here. I want to test something. All right, so let's say ping 192.168.254.3. Good, so trace route 192.168.254.3. Went through just one, it goes through this place straight away. That's a spoke kind of connection. Right. So if you're actually going to the top, it goes through to the top. It doesn't go through the hub to get here. It goes straight away to this. Yeah. And if this is gonna come here, it's gonna pass through the tunnel. So now the best way to actually get this right is this. Now let's say I want to do 168.3.2. Well, give it a second. Start working. Give it a few seconds. Yeah, start working. So now we're gonna trace it. What path does it take? You see, when you check it well, we're going to 2, is it? Right. So it went through where we bring it from. We bring it from PC1. It went through to 1.1. Then it goes to it goes up, right? Right. That's 1. Then here. Okay. Let's do it again. Right. The most important thing is I want you to know that it's going to the tunnel. As you can see, it wasn't going through the physical address. You can't see any physical address here. Right, going to the tunnel. So that's exactly what we need to do, right? So let's try this and see as well. Let's say this. Okay, PC1 to PC2, right, dot, oh, 3.1 was here. So that was why it went to the top, that's why it went up, right? So dot 8, dot 1, dot 2 works, then trace it. You see, it went through just this one straight away. Right. It sent it through to this, to the gateway, and from here passes to the tunnel. So that's exactly what we're trying to show in this lab. So it's actually successful. It took us some time, but we also have to go through this for us to understand properly what we need to do. So in summary, what did we do? In summary, what did we do? We actually deconfigured some routing protocols of this the underlay routers, and we try to reconfigure them, and we try to form ERGRP in this area for the underlay network, right? And we created a tunnel, which is an IPsec tunnel, then we actually connect these remote sites through the tunnel. And it's actually not a point-to-point, it's actually point-to-multi-point, which is DMVPN IPsec. So thank you so much for watching. If you've been with me for a whole time, thank you so much for watching. And if you're not able to watch, you will definitely find this video on my channel. So please like and subscribe for more content. And I'm gonna go back to the CCNA course in the next a few days. I'm working on some other videos.